All right, we'll move to the second part of the presentation. I think Sandy gave an excellent overview about SysML v2 and its importance in the overall plan for digital engineering and digital threads. And I'll go a little bit deeper and talk about specific digital thread stuff. But before that, I also wanted to introduce this idea that he touched upon towards the end of the presentation about this new standard called the Systems Modeling API and Services, which is also called the SysML v2 API. So along with SysML v2, the language, we also have the Systems Modeling API and Services 1.0 specification. And this was really inspired by an RFP, almost 6 years back. And there were certain problems that practitioners were facing with SysML v1 and the tooling around it, which inspired this RFP. And I'll talk a little bit about what is it, and then we go to the demo phase. So the first problem is that there was not a standard approach for programmatically interacting with SysML models. I'll show you an example of that. There were challenges with portability of your applications that are using SysML models. For example, if you build an app or a script and you want to use another SysML or UML modeling tool, you're out of luck. You have to kind of rewrite the whole logic again. That's pathetic. And this whole idea of sharing via XML or XMI wasn't really working out. We also saw that SysML has become way more important than the system engineers comprehended. It has far-reaching effects. It's your blueprint for the architecture of your system, which means it's not just the system engineers, but it's the mechanical, electrical, software, supply chain teams that need to have access to that architecture, to that blueprint. And that's not possible if the SysML model is locked in a desktop app. And that was becoming very challenging. And of course, when you start to build a digital thread where you want that system model, that blueprint to be available and traversable across a complex IT network, you really cannot do it with just a model trapped in a desktop app. And this is very much lined with DoD instruction 5097 that talks about using system models. It talks about having the authoritative source of truth for the system as a whole, but also talks about digital threading with that system model. So that's where the SysML Systems Modeling API and Services 1.0 specification came about. Its objectives are pretty clear. It provides a standard set of services to access and navigate on KerML, which is the high-level language above SysML, kind of the next UML, as I might say that. So it provides services to access and navigate on KerML-based and specifically SysML models. It facilitates interoperability between providers and consumers. You will see in my presentation that SysML v2 is really opening up the marketplace. We see many set of providers and many set of consumers who will be providing services using a standard API. It really standardizes the types of requests that you can send from a consumer to a provider and the types of response a consumer can expect back from the provider. And it provides a platform-independent model of the services, but also provides two platform-specific bindings, which is the REST over HTTP API and the OSFC API. So the architecture for the API looks something like this. You've got a high-level definition of the API, the SysML v2 API, also formerly known as the Systems Modeling API and Services 1.0. And then you've got two platform-specific bindings. And I'll be demonstrating the REST over HTTP API in action live with Syndeia today. But also there's a cookbook. It's a public repository. Links will be available in the presentation after this talk is over. I can also share some of those URLs to you on the chat for some of you who are eager to get access to them. But there's also a cookbook that shows types of things you can do with an API. So let's look at reality. Where were we, before? Where are we actually today? And where we want to go and where we are going. So this is the reality today. If you are developing an application or a script or a piece of software or a custom script, and you really want to extract data out of a SysML model, and let's say you're an enterprise that has got multiple UML SysML modeling tools. The picture on the left-hand side shows your plight today. You really have to create different variants of your app or your script because these different tools have different APIs in different programming languages with different payloads and data. So if you want to get a requirement or a block from a model in SysML provider 1 versus provider 2 or 3, you're out of luck, right? Separate APIs and desktop or app if it exists. On the other hand, with SysML 2.0 API, Sandy mentioned Q1 next year or hopefully this year, end of this year, you're going to get a common API. The vendors are working really hard to implement a common API, which is governed by the Systems Modeling API and Services. With that unified API, you could really use any modern programming language because this API is based on standard REST over HTTP protocol. It's got the same payload, the same data definitions, and it is web-based. So no, your model is not going to be trapped on a desktop app, but it's going to be available over the web. In addition, you also have the textual syntax that Sandy talked about, and that could be another way of sharing models or version managing them in a very IT controlled environment or sharing with people outside your IT network. But generally, the API is going to be providing that interoperability layer with SysML v2 models, and you'll see that in action today. So that's kind of a high-level overview of the systems modeling API and services. I'll have some slides at the end that tell you how you can participate, how you can join that effort. But let's get to Syndeia. Let's go to digital threading. As you know, Syndeia is a digital thread platform that provides you the ability to kind of connect to different data sources. And you can see system architecture is one of the many data sources that Syndeia connects to. And we have developed common APIs to work with Cameo and Rhapsody and other SysML and UML modeling tools. But what's really cool for us is to use SysML v2 API as a standard mechanism of reading and writing system architecture data, which means that if the different vendors actually implement the SysML v2 API, we would be an application that will be able to connect to all of them without writing or changing a single line of code, which is great for us and great for other people who are trying to consume and do things with system modeling data. So that's one thing. And then obviously, as you know, Syndeia takes that data and it makes it available through a common REST API of its own. And that API is used by our platforms, our tools, like our plugin environments or web dashboard or visualization capabilities. But also, because it's available through standard REST API, you can use it in your own program and projects in your own business intelligence platforms that are being used across various stakeholders. We have a rich history with SysML v2. In June of 21, which is 3 years ago, Syndeia 3.4, that appears to be history right now, was released with SysML v2 API integration already baked into it. That was the first commercial support for SysML v2 API in the world. So that we're very proud of that we kind of have been able to do that since that beginning. Then in 2022, the Syndeia 3.5 release extended that capability to also connect with configuration management capabilities in SysML v2 API. As you know, the SysML v2 API has concept of branches and tags. So it's not longer a linear model, but you can have parallel development on the SysML v2 model managed through branches and tags. And Syndeia kind of plugged into that integration as well. In June of 23, we started doing early demonstrations of Syndeia showing some of the transformations. You'll see some of that in action today in this event. Being able to take models in SysML v2 and push them to PLM and ALM and test environments, something that Syndeia already does today with SysML v1 models, something that you already have been using today with v1 models. In April this year, released Syndeia 3.6, which has improved visualization with SysML v2 models, and the model transformation capabilities available as an alpha feature for you to try out. Next year, with rollout of next Syndeia releases of 3.7, we want to improve the model transformation capability, especially start demonstrating the transformation to CAD. Syndeia 3.6 and versions before already have integrations with NX and Creo and other CAD tools with SysML v1 models, and those will also be available through SysML v2. And we'll start showing some of the advanced digital thread visualization reporting capabilities next year with v2. So we've been kind of tracking v2, helping develop v2. In my other job over the weekend, I'm the co-chair of the Systems Modeling API and Services Finalization Task Force at OMG, and I'm also chairing the Systems Modeling Managed Community for the API and Services Working Group, and working very closely with Sandy and Ed to kind of make sure this becomes an industry standard with a wide range of vendor adoption. So what I want to show you today in terms of demo is we'll start with a textual model in Jupyter, and we will publish that model using the standard SysML v2 API to a common repository, which Intercax has been hosting for almost 8 years now, 7 to 8 years now for OMG. And we will then take that same API and be able to use Syndeia to connect to that API and from that repository, and to kind of show you a digital thread that's connecting SysML v2 models to PLM environments, to ALM, some of the tools you see on the right-hand side. We'll use Java for requirements management. We'll use Teamcenter and Windchill for PLM systems. We'll use Jira for showing work breakdown structure, project management kind of thing. We'll show TestRail for test management and GitHub for software version control. And we'll eventually end up with a digital thread that looks like this. You've seen the SysML v2 model out here, but kind of connected to the data in different environments. And we'll be using the spacecraft model that is out of Sandy and Chris's book, Architecting Spacecraft with SysML, an excellent book if you haven't read that before. But it's got a really nice model for spacecraft, and we've been trying to take and see if it can convert that model to a V2 model and trying to demonstrate some digital thread capabilities on top of it. So let's get to a demo. So I'll do this demo in two parts. I've done some recorded part, and I'll show something live. I'll show the digital thread navigation live. But the very first part of it, to take it from the textual model and pushing it to the repository and browsing it first, we'll do a recorded one, and then we go from there. So let's see if I can share my screen. All right. So I'll play this, and I keep pausing as I say. This is the textual model for that spacecraft, as you can see on my screen right now. I'll try to see if I can make this bigger or make this full screen. Okay, this is the textual model for that spacecraft. And you can see there's a package called the spacecraft. There's a spacecraft structure, and it's got the definition of the spacecraft with a payload system, power system, thermal system, a communication system, and things of that sort. So it's kind of a typical V1 block definition diagram, or you see, or block structure that you see. There's also a requirements package, which has the requirements for a spacecraft. You can see that for each of these requirements, there's a doc tag there, which tells you what is the documentation of that requirement. Think about the requirement text that you're used to seeing on a V1 model, but this is typically a V2 model that's being of that spacecraft. At this point, I only have a block structure and a requirement structure, but you also see that I've got certain satisfied relationships that certain elements of the structure of the spacecraft are satisfying certain requirements. So a simple, a textual model that you see for the spacecraft. And I can run that model, and then this is a tooling that the SysML v2 submission team at OMG has been doing. Ed has been leading that tooling. But you can see that it parses that model and kind of confirms that their packet spacecraft has been created, kind of validates that. And I can view that using plant UML in the tooling that is available right now in open source. And I can see the spacecraft specification compartment view. I can also see the same spacecraft requirement structure in sort of a requirement decomposition view using the plant UML diagram, as you can see over here. And then I can also ask to do the same for the spacecraft structure. I can see that in a compartment notation with the parts here. And I can also publish that to see the same spacecraft decomposition. So this is very similar to the block definition diagram that you're used to seeing. But think about it. This is all happening in the textual notation. So far, the API has not been used. We're purely in the textual environment. Someone is authoring the SysML v2 model in a textual environment. And it's just being validated, and we're rendering that textual model, which is being parsed to a in a kind of a decomposition diagram that you see over here. Again, this is all using the pilot implementation tooling that was developed at OMG as part of the SysML v2 submission team. And it's all available open source. You can try this right now, and you can use it. Now, the next step is where the action starts in the next phase. We actually use the standard API to publish that model onto a server, onto a repository. And this is using the standard SysML v2 API, the system modeling API and services. And you can see it's actually created a project called Spacecraft with that timestamp. And you can see at the bottom, there's an ID, a UUID for that spacecraft. So that's where the model is now being pushed. So some engineer working in your organization, building the SysML v2 model, publishes that model to the repository after validation. And now the fun begins with Syndeia. So within Syndeia, we'll start in a second. We can log into the Syndeia web dashboard. I can see my digital thread project dashboard right there. I mean, this server is a test server. It's got a project, but it also has certain repositories and containers and artifacts, which we'll dive in later on. But what we're going to do is go to the repository manager view and go to SysML v2 and look at SysML v2 SST. And when I expand that button, the top button to that repository, what is it doing? It's accessing that standard SysML v2 API in live mode and fetching all the projects that are available on that repository through that standard SysML v2 API. This capability has been available for the last 3 years. I'm not showing you anything new. You probably would have seen me demonstrate it. You actually have access to it. If you're a Syndeia user, you can do this with Syndeia 3.4 or 3.5 or 3.6 today, right? Although if you're at 3.5, we would recommend you to upgrade to 3.6, but you can do this today. But the cool thing you see there is that it's very responsive, right? The SysML v2 API is actually pretty responsive. responsive. When you expanded that repository, it fetched all the projects right off the bat. And we're going to narrow down on one of the projects, which is that Spacecraft module, which was just published, right? So this is a Spacecraft project. You can see the date. I did this recording a couple of days ago. So you can see the Spacecraft model that was published on Friday. And one of the things you can see in a Spacecraft model is that I can browse the elements. I can see branches. There's only one branch right now. No tags have been created, but I can see the decomposition of that spacecraft in tree-like view, as you're used to seeing. And I'll show you different tree views. This is one tree view where you can actually see the relationships itself. I'll show you another tree view later today where you don't see the relationship, you see a pure part decomposition. But what you're seeing in that tree view is pretty much the same spacecraft packet structure. And so you can look at the spacecraft structure. I can go to the spacecraft part usage, right click, and go straight to the graph view. And every mouse click that was happening there is a live call being made to the API. It's not cached in Syndeia by anything. It is a live interaction. It's a very federated approach. We're fetching the data live. So as the data is changing, it's evolving, you can see the impact of that change. I'll keep continuing. So we are now in the graph view. And now if I expand in the graph view, you can see that that is also fetched live what the decomposition of that spacecraft part usage is. Now, part usage, think of it as like a block usage or block. There's nothing called block in SysML v2. If you're used to seeing it, it's all part definition and part usage, very harmonized as a language. And you're seeing the spacecraft part usage element right there. But every mouse click as it happens, I won't repeat this, is live. It's fetching data live, right? So you can see on the right-hand side, the outgoing relationship from that spacecraft part usage to the different subsystems of the spacecraft. I can proceed with the video. I can change the colors. I can change the display nodes here. So you can see these are called the feature membership relationships. What you're used to seeing as the composite association of the black diamond relationship. This is showing you another view of that, is kind of a graph-like view of the SysML v2 model. The spacecraft part usage has these different components. And I can go and to look at one of those as kind of the avionics system shortly here. But you can see the thermal, the harness, the payload system. And if I expand the avionics system, it will fetch me that the avionics system has got an onboard computer and an onboard controller. If I click on the onboard computer, I can see the flight software and the mission software, and I can kind of navigate this on and on. Again, you're seeing the same structure. So I'll fast forward the video because it's getting boring. Let's go to the spacecraft requirement. I'll go back to the spacecraft requirement structure and see if I can expand the spacecraft requirements. And we'll pretty much the same game. We expand the requirement structure, and you can see the requirement decomposition on the right-hand side. I can zoom in, zoom out from the graph, and I can see the different requirements that are out there. I can fast forward and go to this one of these requirements called the launch vehicle interface requirement. And you can see that this requirement, by the way, has an allocation relationship to one of the spacecraft subsystems. So I can navigate that graph and expand that allocation relationship. And this is an area of improvement for the language and for the APIs and for the visualization. But you can see it's a chain of relationships under the model, which we can hide in future. But you can see that that launch vehicle interface is basically linked to the spacecraft structures and mechanism system. That same thing that you were seeing in the allocate relationship over here, that is expressed in the graph through that chain of relationships over here. So there's a lot of semantic detail in it, which we probably will hide in future visualizations of this, but you can see that there's an interconnectivity. So this is the first part of the demo. You're seeing sort of navigating the SysML v2 model directly. Now let me get to showing you an actual digital thread. So we'll now switch over. I'll go back and the full screen. And I will now show this part live. So we are seeing the same spacecraft model. I'm going to go to my digital thread projects. I've actually built a digital thread called the Spacecraft 2409 right here. You can see it. It's got certain repositories and containers and artifacts. And we'll talk a little bit more about it towards this afternoon when we do the kind of the more live demo. But I'm going to the workspace tab, and I'm going to start navigating that spacecraft model again. And you'll see something fascinating, right? So go to the spacecraft structure, go to the graph view, and I'm going to start expanding it. Again, I can, as I said, I can change the name, I can change the display labels, the colors if you want to, and I look at the spacecraft. Now let's see what you do with the spacecraft. Do you see some of these different color labels have come up? So now that spacecraft is not just a SysML v2 model, it's actually linked to a spacecraft assembly in Teamcenter, which is this dark green node, and it's also linked to a spacecraft assembly in Windchill. Now, I chose two different PLM systems, but for the sake of fun, Maybe I'm multi-PLM house, maybe I'm working with suppliers who are on different PLM systems, and I can actually push this V2 model into different PLM systems. So this was not generated manually. This digital threading was generated automatically. I'll show you in the afternoon in the detailed demo of how we built this thread. But for now, enjoy the thread as built. So if I look at the spacecraft assembly in Team Center, I can obviously right-click on it and look at more details. And I'm in Team Center, and I can see the BOM of that assembly right here. I can see the multi-level BOM in Team Center 14. But I can come here and I can expand this right here, and it will expand. It will fetch the Team Center assembly right here. So one of the things you are seeing is true vendor neutral digital threading happening. You see the graph that is within the SysML v2 model. You see the graph that is within the Team Center environment, and you see the relationship that we have built across them. So you're seeing the digital thread graph as a graph of graphs that's taking the SysML v2 graph, the Team Center graph, and kind of combining it. And you can navigate this seamlessly. You don't know which tool you're in except for the color label, but seamlessly you can navigate this graph no matter where this information is coming from. So I can keep expanding this, right? I can go into the avionics system here, and I can look at more details, and I can go to and other things there. So I can do that, pretty easily from here. If I go to the avionics system here on the SysML v2 side, I can see there's that onboard computer that I have. And if I click on that onboard computer, I see that there's a flight software. And if I go to the flight software, I can see there's actually a flight software module in GitHub. Again, right-click on anything in the graph to go to the native repository. I click on more details, and I am now in GitHub. I can see the actual code if it is there on GitHub. So you're not only kind of navigating this like cache data in Syndeia, but this is a live digital thread with the SysML v2 model connecting, as you can see, PLM and ALM. So actual hardware definitions and actual software, all part of the same digital thread. And this is a pretty responsive view. You can zoom in, zoom out, you can do all kinds of cool things with it. I can similarly do the same thing with the requirement structure. So let me go back here. I'll go to the requirements view, switch to the graph view. I can see my requirements here, the spacecraft specification. I can expand this. Again, this is happening live, friends, right? So this is not a video now. I'm doing this live as I'm talking. And I can kind of expand this from here. You can see now that requirement spacecraft specification is actually linked to a requirement structure in JAMA. Again, we'll talk later about how we build this thread automatically, but you can see that requirement structure in JAMA right here. And there's also linked to a Jira ticket for Space One, and I can expand that, and I can see the relationship within Jira. So you're again seeing a digital thread graph that is spanning multiple repositories, SysML v2, JAMA, Jira. Again, I can right-click on any of these nodes here, and I can go to more details. It will open that up. It will obviously require for my credentials if I haven't supplied those. But once I sign in, I will be taken to that element in that repository, to that artifact right from here. So we are in the functional performance requirement, just right-click. Same thing with Jira as well. You can see that Space One is a Jira task that I've created automatically from the spacecraft specification. If I go to more details, I can be in Jira right here, and I can see that requirement structure we had in SysML v2 was used as a basis to automatically generate this. The requirements that documentation elements that you saw in SysML v2 model in the textual syntax have actually come to as a description of the Jira tickets. And I can see that requirement structure, the composition has been created in Jira as like a block relationships, right? So you can see that Space One is spacecraft specification is blocked by quality characteristics. And I can choose different kinds of relationships in Jira. But the point is that you can create a task breakdown structure in Jira, a multi-level task breakdown structure, right? So that reliability requirement you had is a subset of the quality characteristics, which is a subset of the spacecraft specification. But I can browse that here. You can see the blocks relationship, and you have multi-level navigation right here in here. So that's one thing, right? So you can seamlessly navigate that digital thread graph. But also you can do some fun with it. You can also go to the reports view, and I can start to see some reports, right? So I can see some Jira reports here. This is showing me, let me just do a refresh and see if that has changed. But I can go to the Jira and I can start to see live reports. So remember that SysML v2 spacecraft digital thread has links that go into Jira. Now in the report section, I can actually fetch those Jira issues, and I'm showing you the live status of those Jira issues. So there are 22 Jira tasks that are connected with the SysML v2 model. You can see that number 22. They're all tasks and no stories and no bugs there. You can see the allocation of those tasks by their status. So how many are in backlog, how many in progress, how many done. the priority, major versus critical, and you can see the allocation of those tasks to different people in your team. Right, looking at that SysML v2 digital thread, and so you can see the decomposition there. You can also see reports into the requirements management tool. So it shows you that it's 22 requirements that were in SysML v2 that were pushed to JAMA. We saw a navigation of those. And you can see that requirement decomposition by how many are approved versus draft, how many are high versus, in some cases, priority is undefined. You can see a color-coded table as well. We can also move to the queries view, and I can actually run a library of queries. I can create this library of queries, but I can run a library of queries, and these are persisted within the Syndeia digital thread platform. You can see there are 112 relations. I can ask it to query all the relations. I can ask it to get all the different repository types the data is coming from. You can see GitHub, Team Center, Windchill, JAMA, and of course, our SysML v2 repository. That's right at the center of that. And I can run these queries. I can also write some additional queries like, okay, can you show me all the relations that are coming from digital thread, relations that are coming from GitHub? There's only two, the flight software and the mission software. If I run this query to say, give me all the relations that are originating from or landing on Jira issues, well, this is live, right? I'm basically writing graph queries to interrogate that digital thread graph that Syndeia is managing and create views out of this. So all happening live, all working through the standard Syndeia Cloud API. Let's go to baselines as well. So I know that we have talked about in SysML v2, the Systems v2 API, it has the concept of branches and tagging, which is kind of tagging for baselines. So you can definitely do baselinings of the SysML v2 model. But when you build a digital thread where you're tracking data from different repositories and stitching it together, you really want to do a digital thread baseline. So we've actually, as I was building this digital thread, which again, just to remind you, I'll do it in more detail in the demo this afternoon. But as I'm building this digital thread, I was actually baselining it, right, to show you the baselines. So there's a baseline one where when I transformed the SysML v2 requirements to JAMA and Jira, I kind of create a baseline. Then when I transformed the structure of the spacecraft to Team Center and Windchill, I kind of created more baselines. So I can see there are 3 baselines established. I can actually compare these baselines off the digital thread. So I can pick any of the baselines, make that as a basis, and I can pick the other baseline, in this case, let's say the B2 baseline, and I can see there are 31 relationships that were created when I compare B2 versus B1. What's different? Well, because we added those digital thread relations from a SysML v2 model to those items in Team Center. If I compare the B2 versus B3, for example, if I change that to B3, and if I change the source to B2, I can see there were like 31 added. Well, what was different? Well, those 31 relationships also got built between the spacecraft structure and the parts in Windchill. I can also compare, versus now. So you don't have to just establish baseline, but you just want to change or see what happened since the last baseline versus now. And I can see that after I established that third baseline, I actually added more relations, which I have not baselined right now. So you can see that view as well. Obviously, if we go to the settings tab, you can see privileges, that who has access to the digital thread project. So I'm an author, I've got certain privileges, but my team members actually have read access. So they can go log into the Syndeia web dashboard and they'll be able to do pretty much everything that I did here, which is kind of navigate that digital thread, view the reports, run the queries, and get more insight out of that thing. So that ends my demo. Let's talk about a little bit about a few more things before I kind of open it up for Q&A.